interpolation is actually reverse. Now, given the fxk, you want to approximate back what is the x. Given the y value or the fxk value, you want to approximate the x value back. Okay, and then so if we use a Lagrange inverse interpolation formula, so just now is okay, we want to approximate the fx, but now inverse is given the y value, we want to approximate the x. Okay, what is the x value there? And the formula is actually, if just now you have the summation of Lix, now the L is a function of y, it's the same thing. You key in the Li, okay, just now is Lix, now it's Liy. Okay, and let's say we take focus on the quadratic, okay, Lagrange inverse interpolation. So quadratic, so you have the so this is a L naught, okay, in terms of y. Okay, if just now, if the interpolation, you want to, okay, given x, you want to find fx. So the fx is a polynomial, okay, of, okay, polynomial of, in terms of x, but it's a polynomial of degree n. So the inverse is, okay, opposite, given y, you want to find x. If interpolation given x, you want to find y. So reverse. So if interpolation Li x and then the fxi, okay, or the fxi here you can put, because y equal to fx or yi. So the formula is actually same, is only you change the x become y. So for L naught, okay, and then here this one L naught y multiply x naught, okay, L1 y multiply, okay, x1. Okay, if here this is a, if the, okay, given x you want to approximate y, then you have the L naught x, this is a y naught plus L1 function of x y1 plus L2x y2. So if inverse L naught, okay, is a function of y multiply x naught, L1y multiply x1, okay, L2 is a function of y multiply x2. So look like you x and y, you interchange their position. So okay, if you want given the y, you want to approximate x back, if you use a, okay, polynomial of degree 3, then you have L naught y x naught plus L1 y x1 plus L2 y x2, where the L naught y is actually, okay, numerator y minus the point not from number 1 and number 0. So y minus y1 multiply y minus y2, and then the denominator, you just copy numerator, replace the y by, if L0, replace y by y0. If L1, okay, you see, replace the y by y1. L2, replace the y by y2. So for L1, okay, y minus the point not from number 1. So y minus y0, y minus y2. So for L2, y minus the point not from number 2. So y minus y0, y minus y1. Okay, so when you do the inverse interpolation, so make sure you don't mix up with your interpolation, because they are exchange x and y. Okay, and then the example. Okay, given the same data, y equal to ln x, okay, from 1, 2, 3, 4, 5. Now we want to approximate the value of x that corresponds to fx equal to 1.5. So 1.5, fx is here, y equal to fx. So 1.5 between the last two data. Yeah, the last two data. So the question A, determine the correct value analytically. we know, okay, the function is y equal to, okay, ln x. So y now is 1.5. So 1.5 equal to ln x. Hence, okay, you take exponent, okay, both hand side. So you have the exponent 1.5 equal to exponent ln x. Okay, exponent ln x, you get x. That's why x is exponent 1.5, which is 4.4817. So this is the exact value or analytical value. Okay, B, using quadratic Lagrange inverse interpolation, mean this formula here. Question C, using quadratic Lagrange interpolation and solve the quadratic equation. Question C is actually you use, okay, interpolation formula. Okay, if you use interpolation formula, mean question B, you use this formula. C, if you use, okay, the interpolation formula, your formula is actually, this is fx. Fx is approximately p3x equal to, okay, L naught x, x minus x1, x minus x2 divided by x naught minus x1, and then x naught minus x2, this multiplied by y naught plus, this will be x minus x naught, okay, x minus x number 2 divided by x number 1 minus x naught, x number 1 minus x2, this is y1 for L2, x minus x naught, okay, x minus x number 1, okay, divided by x2 minus x naught, okay, and then x2 minus x1 multiply y2. Okay, equation C, you use, okay, interpolation formula, and then we know fx is, okay, 1.5, right? So you put it here 1.5, and then, okay, you plug in all x naught, x1, x2, y naught, y1, y2. Here you will get the, cos here x times x squared, you will get the quadratic, okay, equation. Then solving this quadratic equation, cause x here, x is what we are going to approximate, but we have the x1, x2, x0 value, y0, y1, y2. Then, okay, you will get to a quadratic equation. So you collect together the 1.5, you get quadratic equation, and then you may use, okay, the quadratic, okay, formula to obtain what is the x. You should got 2x. Cause quadratic, you have two roots. Have two roots, then you have to choose the correct roots. There is a question C here. Using quadratic Lagrange interpolation. This is using inverse interpolation. Then solve the quadratic equation. D is instead of you use a, okay, Lagrange quadratic Lagrange interpolation formula, we can fit a quadratic polynomial using Excel and, okay, obtain the equation quickly using the, okay, the trend line, okay, name there. Mean using Excel, you can get the quadratic equation quickly, and then instead of you do it manually. So mean D is a quicker way okay, instead of you doing C manually. Okay, so any questions here before we proceed? A, we already solved analytically, and then we're going to solve B, C, D. Any questions?
No, doctor.
Okay, if
No,
no, we are
not for
going.
now, doctor.
Okay, thank you. And then A, we have solved it. Now we move the, okay, they already said quadratic Lagrange inverse interpolation. So quadratic, so we take, okay, 1.5 between the last two data, so quadratic. So make sure you take 3, 4, 5, so that your 1.5 inside the list. Don't take 1, 2, 3. If you take, okay, the data 1, 2, 3, so 1.5 outside. Also don't take 2, 3, 4, because the y 1.5 is outside. So the correct way to take is take 3, 4, 5. Okay, then it will take this thing 3, 4, 5. Here 3, 4, 5. This is I is here 0, 1, 2. So this is a x, this is a y, is actually the function of x, y equal to fx. Okay, you want to do the question A, inverse interpolations. Uh, Sorry, A A is analytical. Okay, value is actually your exact. Mean now given y value is 1.5. Your exact is actually exponent 1.5. Exponent 1.5. Okay, so equal, and then exponent 1.5. So the exact value 4.4817. And then now if we use the inverse interpolation formula, L is a function of y. L is a function of y. Like here, I can calculate the error. Okay, so be careful. L, okay, for inverse, L is a function of y. Okay, and then you just need to key in L naught. Make sure you key in L naught correctly. Okay, so the L naught is a function of y, so will be equal to y minus y number 1, y minus y number 2, divided y naught minus y1, y naught minus y2. Okay, then you calculate, just make sure you calculate L naught correctly. Okay, where the y I store in the cell C1. So make sure you constant it by putting dollar in front of column label and after the column label. So y minus y number 1 multiply. Okay, and then I can copy. So D become E. So now I got here x minus y1, x minus y2. So divide. So denominator, make sure open close bracket. Then select your numerator. Control C. Put inside the bracket. Okay. Control V. Select the x. Change it to y naught. Okay. Select the x. Change it to y naught. Hold on. Okay. So check the formula. Okay, before we copy, make sure you check. This is y minus y1, y minus y2 divided y naught minus y1, y naught minus y2. So correct. Okay, then I copied, okay, to L1. So the same techniques. Now you drag it to y naught. Y naught. Okay, and then copy, okay, from L1 copy it to L2. Okay, the cell that outside of the range of the list, drag it back to y naught. Okay, so this is your what we call inverse 1.5. Okay, then the format cell superscript. Mean given y is 1.5, you want to find the x. means your f inverse 1.5 or your x is actually okay L naught y multiply, be careful, is x naught plus L1 y x1 plus L2 is a function of y multiply x2. So L naught multiply x naught plus L1 multiply x1 plus L2 multiply x number 2. So this is the answer using inverse interpolation 4.4851. Then the absolute error ABS. Okay, you can approximate, deduct, exact, or exact approach, or the other way, doesn't matter because we take the absolute value. Let's see, 0.0034. Answer 4.4851, correct. So this is using the inverse interpolation. So when you solve inverse, just be careful. L is a function of y. Don't click x. If you click x, then you're doing the interpolation. If you click x, mean you're doing the interpolation. Mean you're doing when x is 1.5. What's the y? So x 1.5, which is not outside the list. So make sure you are clear in mind. You are doing interpolation or inverse interpolation. So this is question A. Okay, for question B, exactly like this. Now, question B, okay, this is C. Or B is inverse interpolation. C, A is analytic, B is inverse, C is here. Okay, using the Lagrange interpolation formula. Okay, fx. So you have here this one, 3, 4, 5. This is your fx. And then what you need to do is actually plug, remember, plug in all the x naught, x1, x2 into the Lagrange interpolation formula. Okay, this is x minus x1. Okay, x minus x number 2. So x1 is 4, x2 is 5 here. Okay, this is x naught. X naught. For L naughts, remember the L naughts, x minus x number 1, x minus x number 2. And then this is y naught here, y naught. Okay, for L1, L1, you're standing here. So x minus 3, x minus 5 here. And then x replaced by x number 1. Multiplied by y1 here. Okay, so this is L1, this is L2. Okay, L2 is standing here, x minus number 3, x minus number 4 here. And then, denominator replace x by x number 2, which is 5. Then this is y, this is y1, this is y2. Okay, and then you will this one or this thing, okay, 1.0986, okay, divided by 3 minus 4, 3 minus 5, you'll get this value. Okay, okay, I wanna show you. Where's my calculator? Hopefully still not yet end the here. You got here this value 1.0986. Okay, divide 3 minus 4, divide 3 minus 5. So you get here 0.5493. And okay, and you expand x minus 4, x minus 5. Okay, you got x squared, so minus 5x minus 4x, so minus 9x, negative 4 times negative 5, so plus 20. So similarly, okay, you calculate the coefficient for the L1 multiplied the Y1. Okay, you have here, I just change 4 minus 5, 4 minus 3. So 1.38, okay, 1.3863. So you get here, mean this coefficient, you get negative 1.3863. And then you expand x minus 3, x minus 5, you get x squared. So total is minus 8x plus 15. Okay, and lastly, you calculate 1.6094 divided by 5 minus 3 divided by 5 minus 4. Here, I clear it. And the last value, you have 1.6094. Okay, divided 5 minus 3, which is 2. 5 minus 4 is 1. So you get here. So 0.8047. And then you expand x minus 3, x minus 4. So total is x squared. So x minus 4, x minus 3, x minus 7x. Negative 3 times negative 4, so plus 12. Then you collect, okay, the quadratic term, linear term, constant term. Right? You collect the quadratic term here, 0.5493. Okay, you collect your quadratic term, and then this one. So minus 1.3863. Then this one add up 0.8047. So you have here the coefficient for quadratic term is negative 0.0323. Okay, later on you collect the linear term. Linear term, you have this one multiply negative 9, and then negative, this one multiply negative 8. Okay, this one time negative 7. Okay, you collect it, you got what? 0.5493 times negative 9. Okay, second term, negative, negative, positive, so plus 1.3863 times 8. Okay, the last term, okay, you got positive, negative, so it's negative, negative 0.8047 times 7. So you get positive linear coefficient 0.5138x. Okay, and lastly, you collect the constant term. Okay, constant term, same coefficient here, time this is 20. So I'm going to just edit it. Constant. The same coefficient 0.5493 times 20. So I just edit it 20. And then the coefficient is negative 1.3863 times 15. So this is delete this, become negative 1.63863 times 15. So delete it. 15. And then it's positive. The last one times 15. And then this is plus 0.8047 times 12. So you get here negative 0.1521. So this is using quadratic Lagrange interpolation formula. Okay, you plug in all the x node, x1, x2, y node, y1, y2 into the quadratic Lagrange interpolation formula, expand and simplify it, you get the quadratic equation. And then given fx is 1.5, given fx is 1.5, that's why you put it here 1.5 equal to negative 0.0323x squared plus 0.513x 38x minus 0.1521. Then you collect the linear term together. So the quadratic equation here, this is negative, so I bring to the other side to become positive. This negative, then this is positive. 1.25 mean I bring everything to the same side with 1.5. So this one become positive, negative, this is positive, add up with 1.5. So you collect the constant term. So this total become 1.6521, and you can solve it quickly using your scientific calculator. Just go to if you have all calculator, then you just find the equation modes there. You're solving the polynomial. So my calculator here is number 2. Degree, this one is a latest model, you can solve up to degree 4. So this is quadratic, so it's degree 2. Key in the coefficient of your quadratic equation, 0.0323 for and then the linear term is negative 0.5138. The constant 1.6521. So you get the first root 11.4336, second root 4.4735. Because you have quadratic, should have 2 roots. And we know that 1.5 is here. 1.5 between 4 and 5. Mean if y equal to 1.5, the x should be in between 4 and 5. Then the correct answer will be 4.4735. 4.4735. And then in this case, if you want to, you can get it, the absolute error. 4.4735. What's the exact here? 4.48. Exact is actually exponent 1.5. Then we get the absolute absolute error. I think got here, not 95. This one 35. Let me calculate again. My calculator. Mode number 1. So you have 4.4735 minus 4.4817. So take the absolute value 0.0082. So this one, this is typo here. So the absolute error is 0.0082. Compare just now. Mean that using the inverse in this case is smaller, 0.0034. This one 0.0082. So any questions here for the technique number C? Questions?
Doctor,
Yes.
we are not choosing the roots 11 because it's not in range, right?
Because you see, you see here, when y is 1.5, the x should be 4, in between 4 and 5. So the correct value is this one, 4.4735.
Okay. So we choose the most suitable one, right?
Yes, yes. Mean you have
Okay.
to observe back, okay, your data, okay, 1.5 between 4 and 5. So the answer should be 4.4735.
Okay, okay.
Mm. Okay, and question, okay, this is a question C, mean for, okay, from the interpolation formula, you obtain a quadratic equation, then plug in your fx value. Okay, so you, okay, and then you get a quadratic root from there, and you have to choose a correct one. Okay, if inverse interpolation formula, okay, like your interpolation but x, you become y become x. Okay, and then another one is fitting the polynomial. You can, okay, to get, okay, to fit the polynomial, in order to get this case equation, you can only take 3 points. If you take, okay, all point, you still can fit to quadratic equation, but the formula, the equation will be run. Okay, and I show you the last one. Mean if you take out all the data, you can also plot. Okay, but then might we show the 3 data, later on show you 3 take out all the data. Okay, A is here, this is B. Mean A is exact, this one is a B. C, with, okay, C you have to do manual. Sorry, C you have to do manual, and then D you can select like this, and then insert scatter plot. So okay, 3 4 5, make sure only 3 data. Even though you select, let's say 1 2 3 4 5, you plot and then you ask to get quadratic equation, still can give you the quadratic equation, but the quadratic equation that you obtain later on, okay, is not comparable with what you do using quadratic Lagrange interpolation formula. You won't get back this formula. Okay, then after that you select here, you right click and then you add trend line. So you can see you got so many, okay, equation that you can add. If this is linear straight line, if I use polynomial, make sure degree 2, and then display the equation on chart, display r squared. So you see this equation compared to this one that we obtain. Cannot. Actually the same. I just want this equation only. Or they select. Should be the same equation. The equation that we obtained from, okay, Excel, actually the same equation, because I compared this one. This is, okay, what I, okay, copied, and then you check back using this one that you do manually, they get the same equation, but using, okay, Excel, a few steps. If this one you have to, okay, do manual, it plug in all the x naught, x1, x2, y naught, y1, y2, okay, and then calculate the coefficient, expand it, expand, simplify, then you get this equation is actually same with what you obtain from, okay, Microsoft Excel trend line, okay, but make sure you choose a quadratic. Then after that, this part is the same. Means C is only we make use of the, okay, Microsoft Excel to get your quadratic equation. Okay, R squared measure the, okay, their relationship, okay, between, okay, x and y. Okay, perfect value, this one, the perfect value is 1. This is 1. So what you obtain, okay, you obtain the y is here from Microsoft Excel, and then given y is 1.5, so you plug in 1.5. So collect the 1.5 together with your constant term, then you get, okay, your final quadratic equation. Use a calculator. Again, you obtain 2 root, and we observe as just now. Okay, when y 1.5 is between 4 and 5, that's why the correct answer is 4.4735. 4.4735. So because the same thing, so question C and D we get, okay, because in Microsoft Excel we get exactly the same equation, okay, unless you take out, if you take out all 5 data and then you ask to get okay, when you take out all the data, okay, if you take out all the data, this one you close it, you see this one, take out all the data here, then you can get the quadratic equation, but will be different equation compared to you obtain manually. Okay, so insert scatter. So you see now 5 point. Let's select the point, right click, add trend line. Okay, choose polynomial degree 2, display equation, display r squared. So you see, if you include all point, 5 point, compare with 3 point, the equation different because they take into account two more point. So if you take out all the point, so the equation will be different if you take out 3 point. So if you take out 3 point, normally you same back with the equation that you obtain manually using here. Yeah, this is manual. I mean, this one we using the quadratic Lagrange interpolation formula, you calculate manually, you got this one. So to obtain this equation, using Microsoft Excel, make sure you just, if here we involve 3, 4, 5 point, then if, to use Excel, make sure you just take out this 3 point. If you take out all point, even though you can get quadratic equation, but will be different, equation. Okay.